And that's Rubisco. That's what Rubisco does, is grab the CO2 and make this much of the reaction occur. Now you've got some acids, but these are the same ones we saw when we broke down glucose. We made the acid, and so really photosynthesis is just reversing the steps that we did. But of course, to go uphill, we're going to have to add energy. So you have to add the energy of ATP, and you have to add hydrogens from NADH2 to make it into a sugar, and energize it and make it into a sugar, and hook the two of them together to make glucose. And so you just kind of reverse the reactions we went over. But notice, according to the overall formula, what? Takes 6 molecules of carbon dioxide to make 1 molecule of sugar. And you can see why. Whoops. Where'd my... I thought I had the... Oh, it'd be like this. 6 CO2 plus 6 H2O, makes 1 sugar, C6H12O6, and releases 6 molecules of oxygen. And so you're going to have to do this 6 times in order to get enough molecules to make 1 molecule of sugar net. And so by the time you've done it 6 times, okay, down here, here's a 1 carbon molecule, carbon dioxide, makes a 6 molecule, or if you take 6 1 carbon molecules, you can, and combine it with 6 5 carbon energized sugar molecules, you get 6 carbon acids, break them into 12 3 carbon acids, energize and reduce those to 12 3 carbon sugars. Okay, that's what I was trying to get to. So now you've got 12 3 carbon sugars. 2 of those 12 you can make into 1 glucose. Take 2 3 carbons, add them together, you get 1 6 carbon sugar. That's the glucose, that's the harvest of photosynthesis. But you've got 10 3 carbon sugars left. What do you do with them? And the answer is complex prerequisites and recycling your prerequisites. If you're going to do this more than once, you've got to get back your energized sugar molecules that you started with. Well, how many carbon atoms are there in 10 3 carbon sugars? 10 times 3 is 30. Okay, there's 30 carbon atoms over here. How many carbon atoms are there in 6 5 carbon sugars? 6 times 5 is 30. Okay, and so you can do this. Okay, and so you use 2 of them to make the molecule of glucose that you really wanted to make, but most of your energy, notice that, is in recycling what it was you started with. You get very little product and an awful lot of effort going into making that little bit of product. And so how are you going to go from 12 C or 10 C3s to 6 C5s? And so here's some biomath, and this is just hilarious. Okay, and you've got a whole bunch of enzymes that do this. Now, no theological connotations implied, but this is called the Calvin cycle. Okay, and so you take 4 of these C3s and combine them, and you get 2 C6s. Now, not the same as this C6 over here. That's the one you saved. But take 4 C3s, make 2 C6s. Well, that makes sense. 4 times 3 is 12. 2 times 6 is 12. You take the 2 C6s, split them into 2 C2s and 2 C4s. Now, the 2 C2s can be combined with 2 of the other C3s to make 2 C5s, and you're a third of the way home. See how clever that was? Yeah, you got the C6s, split them into C2s and C4s. Then you took the C2s, combined them with the C3s to make C5s, took the C4s, combined them with 2 more. Now we've used these, Take these 2, combine them with the C4s, and C4 and C3 make C7s. You split them into what? 2 C5s and 2 C2s, combined with the last 2 C3s, and you're back where you started from. Okay. And each of those molecules has an individual name, and of course sometimes there are multiple steps implied, and they use ATP energy. That's the way God makes this happen. By the way, who can do that? You can't do it. I can't do it. Trees can do it. Grass can do it. Guess what else can do it? Blue-green algae, cyanobacteria, stromatolites. The oldest fossils on Earth, proof positive that life started simple. These blue-green algae on the west coast of Australia. They still live there, still doing the same thing. And these, quote, simple, primitive forms of life can do what? They can take seawater and sunlight and turn it into life. They can do all those steps in glycolysis. They can do all the steps in the Krebs cycle, all the steps in electron transport, all the steps in photosynthesis like that, plus a lot of others. They can make their own DNA. They can replicate their own DNA. They can make cell walls. They can trap sand grains. Wow! Is that a primitive form of life? And what? Evidence of creation, well designed to multiply after their kind. They're still doing the same things today. And so it's really kind of awesome. Now, for some reason, I left out the transparency that went with this. But of course, what we're looking at here is overall the second law of thermodynamics, isn't it? And so if you have energy, by the way, some people, kind of misunderstand the second law in some way. They say the second law says you can't get any order. No, the second law says you won't get order by time and chance. That just random processes won't make things more ordered. But the second law says you can get all the order you want. What? If you pay the price. Now think about it. This is something magnificent to leave you with. Why couldn't all the king's horses and all the king's men put Humpty Dumpty back together again? Was it a lack of energy? No, they had gobs and gobs of energy, didn't they? They didn't apply the energy properly to the problem at hand. Now, the evolutionist says, second law is no argument against evolution because the sun's shining. And as long as the sun's shining, that's enough energy to power evolution on Earth. Is that true? Yeah, that's true. There's enough power, there's enough energy to make evolution happen. There was enough energy in all the king's horses and all the king's men to put Humpty Dumpty back together again. What did they lack? Applying the energy to the problem at hand. You run out of gas on the freeway, but you've got a peanut butter sandwich with you. Is there enough energy in the peanut butter sandwich to run a car 20 miles? Yes, there is. Stuff it in the gas tank. Does it work? No, it doesn't. So just having the energy doesn't solve the problem. You have to apply the energy to the problem. So you run back and bring back a 5-gallon can of gas, open the hood, pour the gas on the engine, toss in a match. Okay, now it doesn't work. You can have the proper energy misapplied, and you still nowhere. And so you got to get the right energy in the right place at the right time. And then you can make all the energy you want. And so if you have the sun shining on green plants that have a whole suite of energy,